Hello everyone, my name is Dr. KCH Apparao, working as an associate professor in mechanical engineering department. Today, I would like to explain about the merchant theory. So, this theory mainly used to find the different forces which are acting in orthogonal cutting. We'll see. This one is the course outcome for this topic. At the end of the course, students should be able to recall the importance of geometry of cutting tools, coolants, and tool materials for the analysis of the material. So, okay, for the study of orthogonal cutting forces, we use the merchant theory. For applying this merchant theory, we will consider some assumptions or some conditions or some assumptions. Okay, so considering a orthogonal cutting operation, two-dimensional orthogonal cutting operation. So these are the assumptions have been taken for applying the merchant theory. The first one is the tool is perfectly sharp and there is no contact along the clearance or flank uh, face. You know this one is the tool bit, workpiece, shear surface, workpiece. So this is the clearance. So there is no contact uh, along the clearance or flank face. So this one shows the chip. You know this. So next assumptions we will see the cutting edge is a straight line. So you can see this is the straight line cutting edge extending perpendicular to the direction of motion. So direction of motion perpendicular uh, and generates the plane surface as a work moves past it. Next, width of the tool is greater than greater than the workpiece. So the width of the tool is greater than the workpiece. So that is the one more assumption. Next, depth of cut is constant. Here there is no variation in the depth of cut. So we assume that depth of cut is constant. Next, work moves relative to the tool with uniform velocity movement. Next, shear surface. So shear surface is plane extending upwards from the cutting edges like this one. This is the shear surface you can see. So the angle is equal to theta, that shear angle. So next one, the chip does not flow to either sides. It flows on the flank surface of the tool. Next, a continuous chip is produced with no build-up edges. There is no any defects of build-up edges. Continuous chip is produced and flows on a flank face of the tool. So these are the assumptions for this application of the merchant theory. We will see in previous class also we already discussed the uh, merchant circle in which we have three triangles also. So triangular method we already explained in previous class also. This one. So this one is the workpiece. This is the cutting tool. This is the shear surface, shear angle. So this one is the workpiece. Okay. And this is the chip movement. You know this one. Okay. So the first one, this is the FC, cutting force acting on this direction. That is the FC, cutting force. You know this one, FC. If you draw one circle along this one. So that is nothing but a merchant circle, you can see. So this one you can assume that this is the merchant circle. So Ft is the tangential force. So Ft, tangent or thrust force, you can observe here. Next to R is the resultant force. Resultant force. This one is the diameter of merchant circle. So next circle we can see that one is the. So here you can see this is the Fc and Ft. R is the resultant according to Pythagoras theorem. R is equal to resultant is equal to under square of under root of F, Fc square plus Ft square. So if you want to find out the angle, so you can take this angle is equal to, so this is the Fc, this one is the Ft. Okay, so the angle is equal to x here, so it is represented by x. Okay, so tan x is equal to opposite side, that is the Ft by Fc. So by using this triangle you can find out the resultant and angle also. So next to shear triangle. So this one is the shear surface. Force acting along the shear surface, that is the shear force Fs. You can see like this one. So normal to this Fs, that is the Fsn. Okay, normal shear force. Next to by using this triangle you can find out the, because you know that this is the shear angle theta or pi, not theta, pi. Then the triangle is like this one. So this is the pi, this is the triangle 90 degrees. So next to the total angle is equal to pi plus x, we know this one. If you consider this triangle, then automatically radius is the same, fs square plus fsn square, and tan of total angle x plus pi is equal to fsn by fs. So by using these relations, we can find out the triangle. If you know the triangle, you can find out the forces also. So last one more triangle that is related to friction. So frictional triangle. So friction is acting like this one. Just I am taking in downward direction. So Ft is a frictional force. You know that perpendicular distance of frictional force is the normal force, capital N. Okay. This is the angle, rake angle, gamma or alpha. You can represent gamma represented by gamma or alpha. That is the rake angle. This rectangle is the just like flank surface to vertical line, indexing line, the angle between the flank to indexing line. So that is the rectangle. Okay, so this one is the rectangle, that one a gamma. You know that this angle, so beta is the coefficient of friction, you know this one, coefficient of friction. If it is coefficient of friction, then angle is equal to, this one is the 90 minus beta. 90 minus beta. So you can take the triangle also. So this is the x, this one is the 90 minus beta, this is the gamma angle. So by using this triangle, you can find out the by, if you consider this is the total is the 90 degrees, then you can find out the x value from this from this angles also. Because x plus 90 minus beta plus gamma is equal to 90, 90, 90 will be cancelled, and x is equal to beta minus gamma, or x plus gamma is equal to beta. So these are the formulas. You know that, so this is the N, this is the Ft, and by using this one, you know the formula of frictional forces. So mu, coefficient of friction, is equal to tan beta. You know this one, this formula. Next to, in last class we already discussed that energy for cutting. Energy for cutting is the cutting force into velocity. So that is the energy. Energy of the friction. Friction means loss of energy. F small f, and v velocity of the chip. So this one, by using this one, you can find out the percentage of power lost in friction also. So this one is the formula. Okay. So now we'll see. We'll find the formulas for the um, different forces, just like FC, cutting force, FN, thrust force, FS, shear force, FSN, normal shear force, and F small f, frictional force, and FN. So not F, this is the N. So tangential force, normal force. Okay. So we'll derive the formulas for this one by using this angles. You know the angle, that one. Here you can see the triangles. The first triangle is the FC and the FT, and the resultant is equal to R. So that is the triangle one. Next triangle is the shear surface shear force Fs and Fsn, and the resultant is the R. So next triangle is the frictional related triangle, that is the F and N. So angle is equal to beta. Angle is equal to beta. So these are the three triangles in a circle. This is the merchant circle. So by using this triangle, so we can find out the formulas for the different forces. You know that the x value already find out that one. X is equal to beta minus alpha or gamma, anything you can take. Alpha or gamma is nothing but so this is the alpha or gamma, nothing but so rake angle. So pi is the shear angle, you know this one, shear angle. Beta is the course frictional angle, angle of course friction, quotient of friction. Okay. So these are the different angles. By using this angles, we can find out the formulas also. First, we'll take this triangle, that the triangle which is related to FC and FT. Okay. This is the triangle. Uh, just here, we are taking the two triangles also. One is the triangle one. This is the triangle. This is resultant and FC, and this is the FT. Okay. Just we are taking one more triangle, that is the FS, CF force, and this one is the FS. Okay. Just we are extending a line here, like this one. We are extending like this one. Okay. So then you can take this. This is the shear angle. This one is the beta minus alpha. Okay. Angles, we know this one. So by using this triangle, first we will find out the Fs. Fs is the shear force. Shear force formula. For this one, you can take this total triangle, this triangle completely. You can take. Okay. So by using this triangle, we can find out the Fs value, because this is the angle pi. So this one is the adjacent side. This one is the opposite side. This opposite side distance is equal to this distance. You know this one. Okay. Mm, First, Fs is equal to, you know this one. Fs is equal to adjacent side into cos pi, because cos pi is equal to uh, adjacent side by hypotenuse. Right? So hypotenuse is equal to here Fc, and this one is equal to Fs. This force is equal to Fs. So by using, so just this distance is equal to Fc cos pi. Fc cos pi. Based upon the Pythagoras theorem. Fc is the hypotenuse, and this side is equal to Fs. So Fs is equal to Fc cos pi, but Fs is equal to up to this one. Best we are finding total distances. So for requirement of Fs, you have to subtract this distance. because this distance is nothing but here you can see. So this distance is nothing but this distance. Okay. So this is the opposite side to angle pi, because this is the angle pi. This is the normal to that fs. So automatically this angle also pi. You can check that one also. Okay. So then uh, here ft is the ft is the hypotenuse, and this is the opposite side. So this distance is equal to automatically ft sin pi. ft sin pi. So it means this distance, total distance is equal to fc cos pi. fc cos pi according to this triangle, fc triangle. Okay. This distance is equal to ft sin pi. Just you have to subtract this one from the total fc cos pi. So fs is equal to, the formula of fs is equal to fc cutting force cos pi minus ft thrust force into sin pi. This is the formula. The similar manner we can find out the fsn also. Fsn is the distance from this place to this place. Okay, this is the fsn. You know this one. Fsn is equal to so first fc sin phi. So fc sin phi. So this is the distance you are taking. This is the fc sin phi. Okay. So this distance is nothing but this distance. This distance. This distance. So it means fsn is equal to this distance plus this distance. This distance. This distance is equal to adjacent side to this triangle. Automatically, that is the ft cos phi. So fsn is equal to up to this one, that is the fc sin phi. From this point to this point, that is the fc ft cos phi. So FSN, the formula of FSN is equal to FC sin phi plus FT cos phi. So by using this triangular formulas, you can solve. Just you can find the formulas like this one. You know, next to resultant. Resultant by using any triangle, you can find out the resultant also. So if you take this triangle, so this is the triangle. So if you take this triangle, this is the triangle. So resultant R is equal to FC. So this is the FC cos phi, because this is the adjacent side. Okay. So FC cos phi, the angle is equal to beta minus alpha. So this is the formula for the resultant uh, formula. Okay. So similar manner, by using this triangle or this triangle, you can find out resultant also. So here Fs Fs is equal to, by using the resultant into cos phi. So R into cos phi. So cos phi means this total triangle angle you have to take phi plus beta minus alpha. So phi plus beta minus alpha. So by using this triangle and this angle and this total triangle, you can find out the Fs also. So Fs has two formulas. If the cutting force and thrust force uh, would be given, then you can find out the Fs by using this formula. If the resultant and the different angles have been given, so automatically you can find out Fs by using this formula. Okay. So next, similarly, Fsn, the formula of Fsn with respect to resultant, that is the R sin phi plus beta minus alpha, similar to. Okay. So by using resultant and angles, you can find out the Fs formula. Otherwise, by triangular method, you can find out the Fs formula. Okay. So these are the final formulas for Fs, Fsn. So resultant formula, Fsn, Fsn uh, by using the resultant and angles. So next, by using this remaining two triangles, it means the triangle of friction, you can find out the frictional forces or cutting forces also. You know this one, this is the horizontal line, that is the FC. You know this one. So if you extend like this one, the lines, this line and this line. So this FC, this is equal to this FC. So here FC means the distance of this plus the distance of that one also. Okay. So this is the distance means opposite side to the alpha. This is the distance is the adjacent side to the alpha, because it is the alpha means this one also alpha. So because the tangent line, normal lines or tangential orthogonal lines also. Okay. You know this one, this is the beta, is the coefficient of friction. Mu is equal to coefficient of friction. Frictional angle is the beta. So by using this one, you can find out the FC. So FC is equal to this distance. This distance means force, that is the frictional force, FF into opposite side. Opposite side minus sine alpha, plus this one is the n into normal force into cos alpha. So this is the formula. So by using this formula, you can find out the FC, cutting force. Okay. Similarly, FT also you can find out. The FT is the, this is the distance. So this one is the distance of F cos alpha. So from F cos alpha, this is the total distance is equal to F cos alpha. So from the total distance minus this distance is equal to N sin alpha. Okay. So it means Ft is equal to F cos alpha minus N sin alpha. Okay. So if you find out this Fc with sin alpha and Ft with cos alpha, you will get the F value also. Because plus n cos alpha sin alpha minus n cos alpha sin alpha will be cancel. If you add this one, just then f of sin square theta plus cos square alpha, sin square alpha plus cos square alpha is equal to 1. Then f is equal to fc sin alpha plus ft cos alpha. Okay. If you know that f, automatically you can find out the n value also. The n value is equal to ft cos alpha minus ft fc sin alpha. Here, just to we subtracted, and if you add this one, you can find out this formulas also. Otherwise, multiply fc with cos alpha and ft sin alpha, you will get the n value. So in this way, just you can, by using the merchant circle, you can find out the formulas of every parameter, every force parameter, that is the fc and the fs and ft and fsn and ff and the n. So these are the forces, different forces acting on that orthogonal cutting. Okay. So now we'll see the coefficient of friction. Coefficient of friction is equal to tan beta. If the beta has been given, would be given, then you can find out the mu value. Otherwise, by using the formula, mu is equal to f by n. F formula, you know that fc sin alpha plus ft cos alpha, and the n value, you know that fc cos alpha minus ft sin alpha. Okay. So by using these formulas, you can find out the coefficient of friction also. So then, if you simplify this one, you will get this formula. Mu is equal to fc tan alpha plus ft by fc minus ft tan alpha. So this is the formula. So by using this one, you can find out the coefficient of friction also. So this one is the just factors affecting the merchant theory. Just like fs is equal to with respect to resultant, we already saw in the previous slides also. So this is the formula for fs with respect to r, by using this triangle of this one. So similarly, fc by using the triangle of this one with respect to r. So this is the formula. Then ft is equal to, this is the formula. So resultant, by using this one, you can find out also resultant formulas. So these are the different formulas. Okay. Next we can find out the shear stress also. Shear stress is equal to shear force Fs by shear area. Shear area we already discussed in the previous class. That is the beta by sin pi. So if you substitute the values and Fs values and just a As value, you will get this one. So assuming beta to be independent of pi, maximum shear stress, it means independent means derivative of shear stress with respect to pi should be 0. If you solve this one, you will get the finally this relationship pi is equal to this is the equation, merchant equation, you can see. So these are the just like merchant theory to find the different forces acting in orthogonal uh, cutting. So we'll solve one numerical which is related to this merchant circuit. In an orthogonal cutting operation on a lathe, the following data were obtained. The first one, the cutting force, it means Fc has been given. This is the Fc, that is the 120 kg. Next, feed force or thrust force, Ft is equal to 30 kg. Okay. Next to rake angle also given alpha or gamma, anything that is the 15 degrees. So next to feed rate also given. Feed rate, feed rate is equal to. So feed rate, it means uncut chip thickness, that is the T1. You can take T1, that is a 0.2 mm. Next to chip thickness also given, that is the T2. T2 is equal to 0.3 mm. Next to depth of cut also given. Next to depth of cut, F is equal to 0.4. Next to okay, diameter, workpiece diameter, that one also given. Workpiece diameter T is equal to 120 mm's. Next, one more thing, that is the cutting speed also given. Cutting speed is equal to 100 plus minute per minute. Okay, just this is the 100 per minute. By using this data, you have to find out the calculate the chip thickness ratio. You know that R is equal to chip thickness ratio T1 by T2, and cut chip thickness by chip thickness. You know that formula. Next to shear angle, you have to find out pi value. You have to find out. Next to coefficient of friction, mu value also you have to find out. Next to frictional angle, so beta you have to find out. Next, shear stress and shear strain also you have to find out. Shear stress Bt by sin alpha. Shear strain also have. Last class we already discussed that one. You know that formula also. Okay. First one we will see the uh, chip thickness ratio. Chip thickness ratio R is equal to T1 by T2. T1 is the uncut chip thickness and T2 is the chip thickness. So the value of that one is equal to 0.2, 0.2 by 0.3, that is the 0.67. Okay. So next one is the shear angle. Shear angle, you know the formula we already derived in a previous class also. Tan pi is equal to R cos alpha by 1 minus R sin alpha. Alpha or gamma, anything. So that is the rake angle. So you know that R value, that is the chip thickness ratio 0.67 into gamma is the rake angle. So 0.67 cos 15 by 1 minus 0.67 into sin 15. So this is the value. So from which you can find out the shear angle, that is the pi is equal to 38.061. So this is the value. Okay. So next to tan x. Uh, Tan x means you know that to triangle. So this is the x, this is the FC and FT. Because FC and FT both parameters have been given. So by using this triangle, you can find out the x value also. That is the tan x is equal to opposite side Ft by Fc. You know that Ft is 30 by Fc is 120. So 0.25 also this value. Okay. So Then you can find out the angle of this one. X is equal to tan inverse of this 0.25. The angle is, the value is equal to x value, angle is equal to 14.036. Okay. If you know this one, you have to find out the beta. So because uh, x is equal to beta minus gamma, uh, then beta you have to find out, because the formula x is equal to beta minus gamma. We already discussed in previous class. Then not x, okay, beta minus gamma. So then from which we have to find out the beta. Then beta is equal to x plus gamma, that is equal to 14 plus gamma. So gamma, uh, that is shear angle is equal to 15. Okay. So it means 14.2036 plus 15. So it means 29.06 the value. This is the frictional angle. So next we'll see Fs, because you have to find out the coefficient of friction. Before that, you have to find out the shear angle also, shear force. Shear force is the formula is equal to Fc cos pi minus Fp sin pi. So by Fc you know that, Ft also you know that, cos pi angle also you know that, sin pi angle also you know that. If you substitute the values here, then you can find out the Fs value. Okay. So Fs is equal to 75.99. So in this way, just you can find out the Ft values and Fsn values, and every parameter we can find out. Next, one more question has been asked. That one is the coefficient of friction. Then you have to uh, solve this one. So what would be the answer? Because you know the formula V is equal to Fc tan gamma plus Ft by Fc minus Ft tan gamma. Okay. So you know that all the values Fc you know given, and Ft value also given, and the Fc and gamma shear angle also has been given. If you substitute all the values here, then you can find out the mu value. This is the 0.555. So that one is the coefficient of friction. Then you have to find out the shear strain also. Shear strain, is equal to cot pi plus tan of pi minus gamma. Okay. So you know that if you pi is the shear angle, you know that one, and the gamma, alpha or gamma is the rake angle. We know that all the values, if you substitute the values, you will get the shear strain also. Shear strength already formulas already given. Uh, that is equal to shear strain, shear stress curve is equal to Fs by area. Okay. Okay. Just to, if you solve the values Fs and As values, then you can find out the shear strength also. Okay. So this is the values. Okay. So this one is a numerical which is related to merchant circuit. So thank you for listening this class. We will see few more numericals in next class. Thank you listening for for the for this listening. Thank you.